Hi everyone. For those unaware, I've been working on my own operating system, FernOS, for the past 5 or 6 months. And since my last video, I have done a lot of under the hood kind of systems level design changes, but I've also added a keyboard driver. So I thought in this video, I would demo the driver, and hopefully you can kind of see based on how we're using the driver and how we're printing to the console, how things have changed since my earlier videos. So anyway, with that, let's jump into it. Okay, so as always, here is our user main function, which is the entry point of the first user process of FernOS. This has not changed. So let's add in code for reading from the keyboard. So let's kind of set up the infrastructure first to do this. We're going to include some header files. All right, so this is the kind of normal syscall file. Syscall kb, as you can imagine, is system calls which deal with the keyboard. And then there's syscall vga cd. This is new. This is kind of what I was alluding to in the intro. It used to be that if you wanted to print to the terminal, you'd do something like scterm put s, which would directly write to the memory, which is displayed by the BIOS terminal. Unfortunately, I find calls like this kind of hard to extend now that I'm adding all these new devices, the keyboard, the disk, things like that. If every device had their own very specific system call like this, it would make my operating system very bloated and very hard to extend. So now whenever I read and write data to and from the kernel, I use something called a handle, which is kind of like the file system handle from last video, but now it's more improved and more generic. So let me show you what that means. So if we want to print to the screen, we're going to have a handle t cd for character display. Oh, let's also define an error. Okay, so if we want to print to the BIOS terminal, we can do error equals sc open, or let's do scvga open, yeah, and cd. If error doesn't equal. So now if we want to print to the screen, we're going to use this handle, and we can do sc write string, handle write string. Okay, let's test this out. Okay, so we get hello world as we expected. So now let's just keep going and actually read data from the keyboard. Okay, let's quit out of QEMU. Okay. So, also, all of the read and write commands technically, or system calls, I should say, technically return an error. In this example, they'll never fail, so I'm not going to check for errors here when we read and write. A more rigorous solution would, so that's a disclaimer. Also, let's make sure to close our handle at the end. CD. Okay, so just like we opened the VGA character display, we're going to open the keyboard now. Handle TKB. Just like that. Oh. This fails. We will exit the process. Okay, and at the end we can sc handle close kb. Okay, so what should we do now? Okay, one thing we could do, which would be pretty simple test, is we can loop forever. And we can, let's think about this. We're going to declare a variable SC_S1 code T. I'm going to explain what this is in a second. I'll call this code. Let me include. Okay, I'm gonna explain what this is in a second. Okay, so now what we're gonna do really fast, we are going to do sc read full, and we're gonna give it the keyboard handle. We're gonna give it our code variable and size of code. So if you forget from last video, well, this is kind of like a reskin of a function from last video. Read full will not return until all the bytes you request are read. So in this case, when this function returns, we know this entire field was filled with read bytes. Again, normally we would check for error. We won't right now. So let's print out our code. So let's do sc handle write format s, and we could say key code ox%x. I think I can do o4x, yeah. And let's give it the code. What's wrong? Oh. We'll give it a character display. Okay, so now when we press a key, it should print out a code, and let's actually make sure that happens. Okay, so we have nothing. Let's press. Awesome. So you can't really see what I'm doing on my keyboard right now, but if I hold down a key like Q, I get OX10, and then when I release, I get OX90. These are called the make and break codes, where a make is when you press, and a break is when you release. If I hold down a key, I'll get a series of make codes in a row. Awesome. So that's the basics of reading from the keyboard. Okay, so now I thought we could use our keyboard driver to actually do something interesting. I think we could start by writing a simple command prompt. And then later, if this video isn't too long, we could have commands actually do something. So let's try this out. So first things first, we are going to need some sort of buffer. I'll call it command buffer, give it a size, and let's have an index equals 0. Okay. All right, so basically we're going to loop forever, waiting for commands, unless maybe the escape key is pressed, and then we'll exit. So let's do while one. And what are we going to do? We're going to have SC_S1 code T. I'll say code. And we're going to do the same thing we did earlier. So SC handle read full KB and code size of code. Cool. And then let's I kind of thought a little bit about this before the video, so let's do, or before recording this, let's do bool is make equals SC_S1 is make code. So basically this is saying, actually I'll just call this is press. That makes a little more sense. This is going to help us a little bit. And then we could say, SC_S1 code T. I'll say make code equals SC_S1 as make code. So the idea here is that you're going to see why I'm adding this in, but this code will be the same regardless of whether it's a press or a release. So if you press Q or release Q, this variable will have the press Q code. So I'm putting this in here because I wanted us to be able to track when the user presses and releases the shift keys so that we can make letters uppercase or lowercase. So let's do bool, I'll say L shift pressed equals false, bool R shift pressed equals false. Okay, so now let's make a nice little switch statement on our key code. And let's just write out some cases. So we'll say case 1 is if we do escape. And we'll say this exits our loop. I'm going to use the controversial goto statement here to do this. Goto end. Okay, what else could we do? There's also case SCS1 enter, and this will be like, this will be when you hit enter and you want to run a command. So in this situation, what will we do? We're going to do command buff I. So we're gonna kind of finish off the command buff by writing the null terminator. Then we're gonna do interpret command buff. Interpret command is a function I wrote before recording. It doesn't do anything yet, but later we can add some behavior. Okay, so we enter our command buff, and then what should we do? Let's think about this. Oh, you know what? Let's also, before we run the command, let's do sc handle write s. We're going to give it, we're going to give it the character display and the new line character. So we're going to skip a line before running the command. And then afterwards, we want to print out the prompt, which I realized I didn't print out in the beginning. So let's make a little prompt. I'll say prompt is going to equal, let's do, so FernOS supports a bunch of ANSI control sequences now. So you can do cool colors and other things. So let's do ANSI, let's do blue foreground and ANSI reset. And oh, I forgot that in the very beginning we should print the prompt also. So let's do sc handle write s, give it the character display, give it the prompt. Okay, this is starting to come together. Okay, so now okay, so going back to where we were, we hit enter, we kind of wrote the null terminator to the command buffer, we skip a line, we interpret the command, and then finally we want to restart. So we're going to say our index in the buffer is 0, and we're going to print out the command buffer again. So let's do sc handle write s. We'll give it the character display handle and the prompt. Okay, awesome. Now let's okay. Oh, you know what? I did this slightly wrong in the beginning. I wanted this to be the make code, and then these things will only actually run if it is a press. And we'll run break no matter what. Okay, so now let's do the shift cases, which should be pretty simple. So we're going to say case SCS1 L shift. So here we're going to say L shift pressed equals is press, break, and then same with the right shift. So R shift. So this is kind of why I did this funky like is press thing and then switching on the make code, is because I kind of wanted this to be entered regardless of whether it was a press or a release, and then we just set L shift pressed equals to whether or not it is a press or not. So that's kind of like a quick aside. Okay, finally, let's do, let's think, are there any more cases? Okay, there are no other cases. So now we do the default case, which is that we want to see if the character we press is actually able to be added to the command buffer. So let's do this. We're gonna do up here. We'll do char c equals sc SCS1. Oh, whoops. So if either the shift keys are placed or either the shift keys are pressed, let's get the corresponding character. So corresponding uppercase character, SCS1 to ASCII uppercase. I'll do make code and then SCS1 to ASCII uppercase, lowercase, make code. Okay. So depending on whether shift is pressed, we'll get the uppercase or lowercase character if it exists. If there is no uppercase or lowercase corresponding character for the key press, 0 is returned. So down here, we can say, okay, first of all, is this a key press? If it's a key press and C doesn't equal 0, so we have a valid ASCII printable character. And finally, is there even space in the buffer for this character? Let's say I is less than size of command buff -1. So we subtract 1 because we always want at least one space at the end for the null terminator. Okay, so finally we can do, if this all passes, let's think about this. We can do command buff I ++ equals C. And, oh, we also want to print it out to the terminal. So let's do, let's think about this. Let's do sc handle right full. We're going to give it the character display and C, size of C, which should just be 1. Okay, that was a lot and might have been a little bit hard to follow, but I hope you did. And I think if we run it now, we could have a basic prompt that does nothing when we hit enter, but at least can accept key presses. So, okay, let's give it a shot and see what happens. So make qamu.bin. Okay, so we have our prompt. It's a little bit dark. Let's see. Hello. Okay, that works. Oh, and I hit enter, and it skips to the new prompt, which is correct. And if I hit shift, hello. Yeah, if I hit shift, I get capital letters. Nice. Okay, one thing I think I forgot to add is it would be nice if I could hit delete and it would kind of backspace. And then also to confirm that our interpret command function call is being called, maybe I could have the interpret command just print out the command for now, just to show that it's kind of being called correctly. All right, let's do that. Okay, first things first, let's, what should we do? Oh, you know what? I would like this to be bright blue because I could not really see the prompt that well. And we could say case SCS1 backspace. If this was a press, we'll say and I is greater than 0. You know, we can't delete anything from the command buffer if it's empty. So in this case, let's think about that. We want to delete a character, so let's do, easiest thing we can do first is I minus minus, which kind of deletes the character in memory, but we also want to delete the character on the screen. So let's do sc handle write s, give it the character display. We're gonna go backspace, print out a space, backspace again. What else did I want to do? Oh, I also wanted to print out the command itself. So let's do, we'll say if command 0 equals the null terminator. So if we get an empty command, we'll just return right away. Otherwise, we can print it out. So let's do, oh, you know what we're gonna have to do? We'll make our character display global. And let's do, command. And you know what we could also do? We could also write some ANSI modifiers. So let's do, is there like a light gray? Yeah, light gray foreground. And then here we're gonna do ANSI reset. Okay, so now hopefully with all that done, the delete character will work. Our prompt will be light blue instead of a dark blue. And when we hit enter, we should see our command, but in our light gray text printed below the prompt. And then afterwards, the prompt should appear again with an empty command buffer. So let's try this out. Okay, that looks a little bit brighter than last time, so that's looking correct. If I type hello and some other text, that looks fine. If I delete, I can delete. Also, let's see if I go to the end of the line, does it still work? So can I delete? I can delete just fine. And if I hit enter, I should get a light gray echo. Looks good to me, although there is no new line, which we should add really fast. Uh-oh. Okay, type to type, echo, awesome. Cool. So now we could go about actually having this command actually do something. Hello. Before we move on to the next part, I wanted to say if you like my videos and you like this project, you may consider donating $1 or $2 to my GitHub sponsors account. All sponsors will one day have their names built into the FernOS ISO, even if it's just a one-time payment of like $1. I do work on this project full-time now, so I have no income. But anyway, with that, let's continue. Okay, so for the final part of this video, I thought we could kind of pull everything together and maybe write a little tool that interacts with the file system. So I thought we could kind of write like an extremely simple version of cat, which would just take a file name and print out its contents to the terminal. So anyway, let's do that. So first things first, we're going to have an error, and we are going to open a handle to a file. We'll call fh air equals sc fs open. And we are going to say the path is just the command, and we're going to give it a pointer to our handle. If error doesn't equal FOSE success, we'll return, and we will also print out ANSI bright red error. I'll say error finding file. Okay. And at the end now, we're going to want to close, close our handle. All right, awesome. So let's, okay, so now we actually want to read the contents of the file, which is something we actually did in the last video. So we'll kind of do it kind of quick here. So let's do char buff 128, and we're going to have a size t redden. Actually, we can put that in here. And we could make this a little bigger. 512. Okay, and we could say error equals sc handle read from the file handle buff size of buff -1. Again, we want to leave room for the null terminator, and then we're going to give it redden, which is how many bytes were read. I know redden is not a word, do not worry. We can say if the error doesn't equal success, so we're done reading, we can break out of this loop. Otherwise, what we can do is we can say buff redden equals the null terminator, and we can print out our what we've read from the file. So let's do sc handle write s buff to the character display, and then let's think at the end, should we print out a new line? Yeah, let's print out a new line. Is that all we need to do? Is it really that easy? Open the file, read into the buffer, set the null terminator, write out the buffer. Okay, I think this is good. And just before I recorded this, I added some files to the virtual disk I'm using. So I copied the make file for this project, which is my make file, and the linker script, which is my linker script. So now we should have access to both from our little command prompt. Let's try it out. Okay, so first of all, if I do a file that doesn't exist, oh no, I forgot. Let's add this in really fast. This should have a new line, and also an ANSI reset. I don't know how I forgot that. Okay, let's try this one more time. All right, so let's try a file that doesn't exist. Error finding file. And now let's try a file that does exist. So my make file. Sweet, that looks right to me. And we could also try my linker script. And now we get the full linker script. Awesome, so you can see we're kind of getting closer to like a real operating system. I hope my next video is about loading ELF files, and then I could build a real shell. It would be annoying if I had to write, if I had to compile the entire functionality of the operating system into the operating system binary. It'd be better if the operating system could read a program from disk like a shell does. So we're kind of getting there, and I hope that'll be my next video. And if you've made it this far, thank you. Consider donating $1 or $2, and I will see you next time.